So I'm Olivier Bierlaire. I usually work for Elastic as software engineer in the releasing team, but I took a step away from that to start my own project named Carbonifer, and this project is essentially to measure and try to reduce the carbon emission of the cloud. So here is a sentence I hear quite often. I have all my infrastructure in the cloud, so I do not emit CO2. Yeah, cloud is magic. You know, everything goes to the cloud, disappear, it's nowhere, it's in the cloud. But actually, no, it relies on machines, servers, and data centers. And those data centers are using electricity. But electricity is clean, right? No, not really. Gonna see that. So let's look at some figures. What is the problem? So data centers are responsible of 20 to 25% of the whole electricity used by the digital sector, including like computers, smartphone, etc., etc. Data center alone are responsible of 20%. And it's estimated to be responsible of 1.3 total electricity worldwide. And if we look at the forecasts, by 2030, ICT is going to be responsible of 20% of the electricity demand, 20% for ICT. And data centers alone are going to be maybe responsible of a third of that. And if we look at the greenhouse gas emissions alongside this electricity demand, we consider that digital technologies are responsible of 4% of the greenhouse gas emission, and it's already old data, basically, and it's data from like 4 years ago or something like that, so it's increasing pretty fast. We estimate that more than 300 megatons of CO2 are emitted by the cloud, and that basically represent the entire emission of all countries like France or UK. That's huge, basically. And congratulations, we just passed and overthrown the civil aviation. So cloud is emitting more than the civil aviation currently. And it's estimated to be around 8%, so basically double by 2030. So that's a huge problem. So that's pretty concerning as a human being, but as a company, what should a company bother? So there is a lot of laws and regulations that are setting up currently. So a lot of regional administrations and state and European Union are setting up some directives and law for that. They are not quite yet there. Going to see that later. It's all showing that you are a greener company. It's also a great tool for having ESG funds. So ESG funds is financial funds that are going to invest to companies that could be claimed sustainable. So obviously you would like to have these money. And it's also a great tool for recruitment and staff retention. It has been shown in some studies that you are more keen to join a company as an employee who is showing some ethics and some sustainability. And same thing for customer retention. Like as a consumer, you are more keen to choose to buy a service or product from a company which is more sustainable. And obviously that leads to cost reduction, because if you are using less resources, that means you're having less costs, obviously. But the problem is, if we are trying to measure it, what is the scope of your company? What is the responsibility of all the emissions? Here is an example. In 2019, Mozilla published their sustainability report. And in that, they showed that 98% of their entire CO2 emission is due to you, the users. So they are encompassing the product use in their calculation. And if you want to go deeper, what does it mean? Is it the product use like Firefox itself, or is it also the computer or the smartphone it is on? Because you probably need a smartphone or computer to use Firefox, and for most of people, they are using only the browser on their laptop. So where to stop? Some people suggested that we should even account the CO2 emission due to Spotify if you're listening to Spotify while you are developing your coding. Because if you need Spotify to focus, obviously, that could be accounted to the CO2 emissions of the company you're working for. So that's a little bit crazy, and it's pretty hard to know where to stop, what is the responsibility. So that's why the GAG protocol came. So the GAG protocol distinguish three scopes. Scope 1 is obviously the direct emission. So basically, if you are burning fuel and you are directly emitting CO2. So basically, your diesel generator, if you have a backup generator, that's where it's going to be accounted. Scope 2 is the indirect emission related purchased energy. So basically, if you or your company have an electricity bill, that's in the Scope 2. And Scope 3 is other indirect emission, also called value chain emission. So basically, transportation of your employees, the freight, if you are shipping stuff, the raw material purchase, and service and good purchased. So basically, if you're operating your own private cloud, it's going to be Scope 2 and 3. Scope 2 for the electricity bill, Scope 3 for the machines you bought. If you are operating a public cloud, it's going to be all in Scope 3. But again, like I'm still not satisfied with this Scope 1 and 2 and 3, because in Scope 3, it's basically everything. So again, in the same example of Mozilla 2019, so you have some figures. It's expressed in metric ton of CO2 equivalent, not megatons. So you can see that the Scope 3 is enormous, and within the Scope 3 on the right side, you have two interesting numbers. The first one is the cloud emissions. It's 5,000 tons of CO2 equivalent per year. And the use of their product, if they are counting it, it's basically like a bit less than 800,000. So as you can see, the cloud is, for Mozilla, still a big share of their emission. But obviously, Mozilla is pretty, it's a particular company because most of their emissions is coming from the users. But if you are like, I don't know, like if you're Netflix or Airbnb, probably your largest emission is coming from your cloud, basically. So 5,000 tons of CO2 equivalent. If you can compare it to flights, it's a flight from Europe to US is a bit less than 1 ton of CO2. So basically it's 5,000 flight from Paris to New York, basically, per year. So what are those regulations? In Europe, we have two regulations which are quite interesting. The CSRD stands for Corporate Sustainability Reporting Directive. So it's going to be enforced in next year for large companies and for smaller companies in 2 years. So it encompasses Scope 1 and 2 and even Scope 3. For SFDR, it's more for financial sector. So basically, they're going to need to report as their Scope 3 the carbon emissions of the company they're investing money into. So that's quite interesting, those two. And for American companies, it's going to be the SEC Climate Disclosure Rule. So it's kind of weird because it's Scope 1 and 2, and Scope 3 is kind of optional. Is Scope 3 if you are committed to report your Scope 3. So that's kind of weird. And it's going to be enforced pretty soon. So you also hear about some commitments and some buzzwords like that, CO2 offset and elimination. So what is the difference? CO2 offset is when you are basically compensating your emission. For example, you are planting trees to cover your emissions. Elimination, or also called abatement, but I prefer the word elimination, it's easier, is basically not emitting CO2. It's basically removing the source of the emission of CO2. So those are two different. I don't want to judge too much, but from my point of view, it's better to not emit rather than to offset it. And again, some other buzzwords. Some companies want to be carbon neutral, net zero, 100% renewable. But basically, what does it mean? So if a company is claiming to be carbon neutral, that means they're going to focus on offset, which means, again, compensating, planting trees. So they're not going to focus on eliminating. They're going to still emit a lot of CO2, but they're going to compensate it. For net zero, they are focusing on elimination. And if there is some emission left, they're going to offset the rest. So they need to be based on scientific calculation to sort this out, but that's pretty much the gist. If a company is claiming to be 100% renewable, you need to be careful if it's powered by or if it's matched by. If it's powered by, that means you are sure that one electron coming into your data center is coming from renewable energy. If it's matched by, that can mean that, for example, you have solar panel on the roof, and it's covering, in theory, the entire need of your data center. But obviously, during the night, you still need to have power, and you take the power from the electricity grid. And in that case, even if you're producing more than you need, you still need to have external electricity, and this electricity could be emitting a bit of carbon. So in that case, it's a little bit biased. So yeah, be careful if it's powered by or if it's matched by. So I have a question first. Are you working in companies which are operating a cloud somehow? Can you raise your hand? Yeah, and can you keep your hands up if you are responsible somehow of managing this cloud, like as SRE, software engineer, something like that? Yeah, okay. And can you keep your hands up if you know what is the carbon footprint of your cloud infrastructure? You know, one person, great. You can talk to me after. So how it's working? So yeah, electricity comes from various sources. You have coal factories, coal plants, you have nuclear power, you have renewable energy, you have hydroelectricity, you have a lot of stuff like that. Side note, nuclear power is considered here as clean energy, which means that it doesn't emit a lot of CO2. I don't want to enter into debate if nuclear is great or not, but in terms of purely CO2, it's considered as green energy, but not renewable. Renewable, it's only hydroelectricity, solar panels, windmills, stuff like that. And this electricity is transferred to your data center with your electricity grid. And once you enter the data center, a majority of the electricity is going to power your servers. But a tiny bit of this electricity is going to be used for cooling systems, AC, the administrative building, even heating of the administrative building. So there is a little bit of electricity loss. And if you have an application running on this public data center, such as your virtual machines, your Docker container, your Kubernetes cluster, anything like that, it's going to be sharing a little bit of those different servers. So basically, with some calculation, you can know what is the electricity used by your cloud infrastructure within the public data center. I'm going to show that. So the Green Software Foundation came up with this handy formula, which is called software carbon intensity. So it's a formula used to calculate what is the carbon intensity, not footprint, but intensity of your software. It's expressed in gram of CO2 per hour. Not exactly gram of CO2, it's gram of CO2 equivalent. Why? Because it's not only CO2 that is emitted when you are generating electricity. Could be some other greenhouse gas like methane, for example, MH4. For example, methane is 84 more potent than the carbon. So in order to not lose everybody in some weird calculation, we came up with this unit which is CO2 equivalent. So it doesn't mean it's only CO2, but it's just we rationalize that as a CO2 equivalent. So to make this calculation is pretty straightforward actually. You have the E. E is the energy consumed by your software. So basically, you know how your software is, you know how much electricity is used by your software. You know what is the carbon intensity of the grid. So depending of the country, depending of the electricity mix, depending if the electricity is coming from renewable energy or coal plants, can be very, very different. And we add that with the M, and the M is the embodied energy. So the embodied energy is what I'm going to show you later. So what is the embodied emission? So the embodied emission is basically the kilograms of CO2 required when the server are being manufactured and when it's going to be disposed. So in this example, if you need 4 tons of CO2 for building a server, so basically you bought this server from China and the factory in China was powered, for example, with coal, there is some data sets and calculation, and imagine you have this number, you know it's emitting 4 kilotons of CO2 while it's been manufactured. If you consider that your device is going to last 4 years, that means each year it's virtually going to emit 1 ton of 1 ton of CO2, and you can even split it by hour, by minutes, and by the percentage of use of your different processes. So for each part of your infrastructure, of your software, you can calculate the share of this virtual embodied emission. That's kind of weird. Like, imagine you have a sofa, you buy a sofa, 1,000 euro, and you want to charge your guests of how long they are going to spend on the sofa. So the sofa has 3 seats. You're going to calculate, like, someone is using 1 seat for 1 hour. You can calculate the cost of this share of usage of the sofa. That's pretty much the same. So that was the M in the equation. For the E and the I, so the E is the energy of the software of your VM per kilowatt hour. So imagine that you have a process using 50% of an AWS instance M4 large, which is 2 CPU, 8 GB of RAM. There is some ways to calculate that, a lot of ways to calculate that, but basically it's just, you can just put some probes in your server. And you know that this software is using 10 watts hour, which means 0.01 kilowatt hour. Then you need to have the power usage effectiveness. So in this example, you are based in AWS Germany, and AWS is publishing their PUE. In that case, it's 1.2, which means if you want to have 1 kilowatt hour in your software, you needed to inject power of 1.2 kilowatt hour. Remember, you need a little bit of electricity for cooling down, some stuff like that. Then you need to multiply it by the carbon intensity of the grid. So it's in gram of CO2 per kilowatt hour. And again, in Germany, I'm going to show you some example later. In Germany, we consider that on average, it's emitting 300 grams of CO2 per kilowatt hour. So every time you need 1 kilowatt hour, it's going to generate 300 grams of CO2. So in this example, that gives you 3.8 grams of CO2 per hour to run your software. So again, to come back to the full formula, you add your 3.8 grams of CO2 per hour for the use to the 1.2 gram of CO2 of the embodied emissions. You weirdly calculated it, and it comes to 5 grams of CO2 per hour. Those are kind of real numbers, let's say. So where did we get this data? So one thing is quite easily, you can easily find is the carbon intensity of regional grids. So you have a very handy tool which is called appelectricitymaps.com, and in this tool, you can't really see it here. I'm going to show you a bit better here. It's kind of better. So in this tool, you can zoom into different countries. For example, in France, it's 22 grams of CO2 per hour, per kilowatt hour. In Portugal, it's a bit more, but still green. So it's today, right now. And in Germany, it's 400 grams. So you can guess where I'm coming. It's just the choice of your data center is super important. And if you pick UK in this example, okay, if internet is working, okay, great. So you can see here that the carbon intensity varies a lot during a day, and it's probably because of this, which is the gas, and that which is the wind. So in this example here, you don't have a lot of wind, so they needed to use a lot of gas to produce electricity, and when the wind is up, they can turn down their gas plant. So it's pretty interesting to have those numbers. And in Europe, I think it's always Sweden that wins, because it's basically everything is coming from hydroelectricity. Going back here. And yes, also the power usage effectiveness. So again, that's the ratio between the electricity entering your data center and the actual use. Different data centers are publishing their data for that. So there are some data that are less available, let's say, which doesn't mean you cannot find it. It's a little bit of a headache sometimes. For example, if you are running an instance on AWS, GCP, Azure, you name it, do you know what is the model of your CPU on that? And it depends. The power usage of the CPU really depends on the make. So for that, we are taking some estimation, average, some coefficient, and it's probably good enough. On the same way, if you are calculating always in the same way, you can compare your different models, basically. So same thing for memory, for storage, for network. So it's pretty hard to find this, but obviously we have some data set for that. Or you can directly measure it if you have access to the machine. Embodied emissions of the hardware, so again, is the electricity used for building this hardware. It's pretty hard to find because, again, like you need to know what is the model, what is the manufacturer, where it has been manufactured, when. So it's pretty hard to find, but again, you can still find that. You have some data sets available. And for the energy mix, I'll show you the map, but the map is showing what's the current carbon emissions, who's the carbon emission in the past days, but what's going to be the carbon emission tomorrow or next week when you're going to launch your product. Who knows? So in order to help you out, there is a lot of tools. One of the most obvious tools are what are provided by your cloud provider. So basically AWS, GCP, Azure, and a lot of others are making available their sustainability dashboard, they can claim it. So in this example, you cannot really read it because it's pretty basic, but basically it shows just the big number. What is the carbon emission of your infrastructure? In this example, it's showing that it's 0.3 megaton of CO2 per month. And that's pretty much all you can know. You cannot deep dive, you cannot, and it's already old data. You need to wait a couple of months to have that collected and aggregated. But still, it's great because with one click, you have your carbon emission. Pretty easy to have. If you want to go to deep a little bit more and to have some more accuracy and more reactivity, you can use some open source tools such as Cloud Carbon Footprint. This one, it's open source. It's sponsored by ToughWork. It basically reads the bills of AWS, GCP, and some others. And in the bill, you have how long you have used your instances, your Lambda function, on which kind of CPU. You have all this data. And they are basically recalculating using some ratio. For example, they claim that they calculated that on average, a CPU is used 50% of the time. You can tune it, but it's still estimations. And if we go in the demo, so that's pretty obvious on this demo that you can filter with your cloud provider, your different accounts, your different service. If you want to focus only on EC2, you can, and you have these numbers. In this example, in March, it was emitting a bit less than 2 metric tons of CO2. And you can break it down, and you have even the comparison with flights, or phones, or trees. That's pretty handy. The only problem I see with that is you need to deploy it yourself. That's pretty much all. It's not a managed service. So that was for having basically the big numbers of your actual use of your cloud service. Now I'm going to show you how you can anticipate it, or you can calculate it a little bit more manually, or if you can embed it in some other tools you can build to manage that. One is named Climatic, so it's a commercial API. It's working not only for cloud computing, it can work also for transportation, freight. They have a lot of data source. So in this example, it's API, and you hit this API with the region. In this example, it's UK with an instance H8 on Azure for 24 hours. And it can calculate you that for those 24 hours, it's going to emit a bit less of 1 kilogram. So that's working pretty well. It's free for open source project, but yeah, that's worth checking out. Another one which is open source and is a free API, but again you need to host it. That's one of the problems. Is called Boa Vista, and it gives you the CO2 emission per use and per manufacturer. So what they call manufacturer is actually the embodied emission. You need to be careful with this manufacturer number because it's the entire lifespan of your instance. So it's not going to be the share per minute per hour or something like that. So it's pretty weird that they are mixing the use, which is for a specific time, and the manufacturer, which is for the entire lifespan. So if you are using a software for 1 hour, it's going to charge you the full embodied emission for 1 hour, which is for the entire lifespan, which is kind of weird. But again, and they have a really nice interface when you can play with that. So you enter your cloud provider, the type of instance, and it gives you so the big blocks are the usage, and you have the manufacturing here in darker blue. And yeah, and you have this, this beautiful API. So another interesting tools, and yeah, and there is a lot of those tools. Another interesting tools is basically focused on getting the power consumption of CPU. So what it does, it reads some device, virtual device on your Linux or Windows, and it can give you the electricity used by your CPU. And because you can monitor everything on Linux and Windows, so if you know what is the share of usage of the CPU for your different process, and calculate that for you. So it's not CO2 emissions, it's just gonna give you some kilowatt hours numbers. And then after you need to make the calculation, but it's already great because those numbers are more real, let's say, rather than the other tool we're working on some estimation, roughly. You know that you're not gonna use more than 50% of your CPU. Here is real data. And my little project, so I started this project with a very small open source command line tool, and this tool is can estimate Terraform projects. So if you're not familiar with Terraform, Terraform is an infrastructure as code tool. So basically you write the infrastructure you would like to have, like the number of instances, on what, on where, and it's gonna deploy it for you. So basically, everything is written, so it's pretty handy to have it in CIs, to have it linted, whatever you want, but also you can read it and make some computation. So with my project in this example, if you want to run a Google Compute instance in Europe, it's gonna give you that, it's gonna emit less than a gram of CO2 per kilowatt per hour. So I'm gonna show you a quick demo about that. So yeah. Here, Europe Central one is Germany. I can make it bigger. Too big. Europe Central one is Germany, and I want 10 instances of M4X large instance. So I kind of consider this is kind of a realistic SME, small company, cloud infrastructure. I mean, doesn't mean anything when I'm saying that, but it's kind of realistic, let's say. And if you run that, in a few seconds, yep. So it tells you that if you deploy this infrastructure, it's going to emit 600 kilograms of CO2 per year. So again, it's a little bit less than a flight from Europe to US. And if you change it to be hosted in Paris, and I shut it down. Great. Bear with me for a sec. Yeah. Still. Again, I haven't saved. Yeah, live demo. Yeah, wait. So if you move that to Paris, you come from 600 kilograms of CO2 per year to a bit less than 100 kilograms of CO2 per year on average. So that's quite significant the choice of the region you are making. That's really important. And some other place you can grab some information is the Great Software Foundation. So they have various projects, but one which is interesting is their awesome list. So if you click on this link, or if you go to the Green Software Foundation website, you can find this list of different tools for different cloud provider, for different languages, if you want to monitor your code, for a lot of articles and resources. So they came up with this awesome list. And now I'm going to make you a quick demo of an infrastructure which is, no, sorry, it's going to come later. So now you know how to measure it. Yes?
Do you know if these tools also have support for serverless applications? So, like Azure functions or something like containerized nodes, maybe?
Yeah, I'm not sure. Yeah, I need to check probably. Yeah. So now you know how to measure it, how you can reduce it. So there is some good practices named green coding or eco design. So obviously, before trying to reduce the cloud emission of our infrastructure, it's better to run better design tools and better design data. The less data you're storing, the better it is. The more efficient is your code, the less CPU is going to use, obviously. So another good thing to do is to pick the right type of instance, the right size, and the last model. For example, if you're picking some Gravitron instance on AWS, it's using ARM CPU, and ARM CPU is super efficient. In terms of kilowatt hour, I think like a regular CPU is around 5, 6, 7, 8 kilowatt hour, and for Gravitron is less than 1. So picking the right model and right machine is super great. But again, I insist, do some eco design on your code. That's really important. But it's another topic. Another good thing is to move to hyperscaler. So basically, if you are moving to AWS, GCP, Microsoft Azure, or some others, they are all claiming to be, they are all committed to be net zero by 2013, 2040 for AWS. And Microsoft Azure even want to be carbon negative, which means they're going to claim to capture more CO2 than they're going to emit. So that's a good way. Another good reason to move there is that they are working actively on their PUE, so basically the power usage effectiveness, how many kilowatt hour they need for having 1 kilowatt hour in their machines. They are working on making their hardware running longer, increasing their lifespan, and they are buying more and more renewable energy on the market. But be careful with that of the rebound effect. Like you see your number of your emissions going down, so you tend to use more and more because that's what is the rebound effect. Yeah, another good thing, if you have your instances on premises, which means you probably need to overcommit. In this example, you need to have 5 machines for spreading your load, and you probably have too many machines just in case you have a surge of traffic. If you are moving to the cloud, it is more elastic, you have more flexibility, so you tend to have less instances, less machines, but highly used. So in that case, you're going to use exactly what you need, but you're not blocked, because if you have a surge of traffic, you can still increase and adjust if required. And I put that to interesting, smaller alternative. So if you want to not be on AWS, GCP, Azure, and you name it, you have some alternative hyperscaler. Exascale, they are based in Switzerland, and they are basically using only hydroelectricity. So virtually their emissions are none, but still they have embodied emission for the manufacture of their hardware. But for the use, it's powered by hydroelectricity. Denver is a French company. They are studied a very interesting project where they are using floating data centers. So basically their data center is going to be on the river and be naturally cooled down with the river. So in that case, they're going to lower a lot their PUE. But again, you have a lot of very interesting projects. Another good practice is to move to use FinOps good practices. So FinOps is, let's say, the branch of DevOps focusing on the costs. So basically the idea is to bring some automation to shrink your costs. A very good example is to turn down instances during the night. If your customers are mostly using your software during the day, a good thing you have a cron, and your cron function is going to shut down instances during the night. So that could be scaling. That could also be auto-scaling groups. So auto-scaling groups so they have different names in different cloud providers. It's the capacity of a group of instances to shrink or to grow depending of different alerts. So if it's going above a certain load of CPU, if it's going above a certain traffic, it's going to scale up. And if nobody is using the machine, it's going to automatically scale down. A good thing to do is also to move serverless. So basically serverless doesn't mean you don't have server. It just means you are not occupying a server if nobody is using your function. So on AWS is, for example, Lambda function, is Google functions, various Firebase, various different technologies like that. So yeah, basically if you have a function there and an API, or for example an API based on those functions, and nobody is hitting this API, it's not going to spin up on any instance, so you're using nothing. And it's going to be deployed only when it's needed. And so basically the idea is to adapt your infrastructure to the demand. So basically you are spending less money because you are adjusting only, you are using only what you need, and therefore you are emitting less CO2 because that's the same principle. But it's not always the case. Like if you have a constant number of instances, so it's going to cost exactly the less, but if you're based on different countries, it's going to emit more or less CO2s. So again, check the electricity map, but those are data coming from Google. So this is showing the average carbon intensity of different regions. And in Europe, you can see that for Google, it's always Paris the best choice. And you have some other worst choice I will not name to not shame anyone. But picking the right country is probably the easiest and the most straightforward way to cut down your emissions. Another good practice is to follow the sun. So basically, as I showed earlier, the renewable energy are very weather sensitive. So if it's sunny, if it's windy, some countries emit less CO2 than the contrary. So same thing for day-night. So again, check electricity maps. And the idea here is to plan your heavy asynchronous task accordingly to the grid. For example, machine learning. If you have some really super big model to train, it's good to have it trained in a country nearby or in the time where the electricity is going to be a little bit greener. Another good thing, I don't have the slide here, is so basically what most of the grids are doing is they need to have a base of, for example in France, a base of nuclear power, providing, let's say, 70% of the electricity of the day. And then they have windmills and solar panels, etc., etc. But if nobody is using that, it's just going to be lost. It's not used. So basically, if you are using that at that moment, you could even think that the electricity is kind of free in terms of CO2 because it's been generated. I mean, your windmill is turning, your hydroelectricity is pumping. So whatever you do, it's still generating electricity. So if you're not using it, it's lost. So the good thing is to plan to take advantage of this loss. And the last thing is to be carbon aware, basically. So the idea of carbon awareness is to have your infrastructure self-adjusting and knowing what is its own carbon emissions. So knowing its own carbon emissions is going to resize, move, or schedule. So there is a couple of ways to do that. One is named temporal shifting. So the idea behind temporal shifting is, again, to plan your asynchronous task when the electricity is going to be less carbon intensive. So some examples are video processing, AI model training, machine learning, database indexing. There's a lot of case study. But at Google, what they did is they they tried that for their own purpose. It's not for their customers, for on their own purpose, to use some API to get the carbon intensity of the grid at various moments of the day and try to plan their asynchronous tasks accordingly. And as you can see in this graph, yeah, you cannot really see it, but yeah, so basically the line in green compared to the line in yellow showing that they are basically putting more loads in the white area where the electricity is going to emit less CO2. And there are some studies showing that this action can result in 45 to almost 100% cut in the carbon emissions. So that's quite significant. Another interesting thing to do is called demand shipping. So basically is to change the quality of service depending on the carbon emissions. So a good example could be that you are reducing the quality of the image of your video when the electricity is emitting a lot of CO2. Obviously, that might not work business-wise, depending on the business of your customers, but that could work. There is, I think it was a university that tried that to publish their video online, and the video player is not playing actual images and just the sound when the electricity is emitting a lot of CO2. And you're gonna get back the image only when the electricity is a bit greener. Another good example could be CI, like if you have a CI building your PRs or your merge request for your developers, you can size it down, your Jenkins server, for example, you can size it down when the electricity is emitting a lot of CO2, and size it up when it's a bit greener, so that will mean that your developer are gonna need to wait a little bit to have their PR built, but you need to make a choice in that case. So basically that's the idea, it's just you are shaping the demand, which is changing the quality of service when the electricity is emitting a lot of CO2. And another interesting thing is spatial shifting. So basically the idea is to put the load in the region where the electricity is emitting the less CO2. There was a conference named Hot Carbon this year, and there was a presentation showing that they basically had 2 data centers in 2 different regions of US, and they have the same software on that, and they have a load balancer redirecting the call from the customer to one of those different regions. And by default, it was redirecting to the closer region of their user. And they changed it a little bit to take into account these carbon emissions. So basically, it was redirecting to the region where the electricity is going to emit less CO2. And they managed to balance those 2 decisions and without any loss of latency, which means the customer will not see any difference. They managed to reduce by 21% their carbon emission with that. So that's quite significant, and they managed to cut it by half with acceptable latency, which means they are downgrading a little bit their service, but the customers still find it acceptable. But they still have those 2 data centers up and running in the same time, but it was already great. So that's why I came up with this demo. So I'm going to present you a quick demo where I have this setup. So basically I will have 3 groups of instances in 3 different regions, Ireland, France, and Germany. And I will have a load balancer in those regions redirecting the call from the customers, and a global load balancer where basically when the user is hitting the load balancer, it's going to redirect round robin to one of those regions randomly. And then I'm going to add a carbon aware scaler. I didn't find another better name. So the idea of that is to look at the CO2 intensity API, basically one day to electricity map or some other provider, and make some decisions here. And the decision would be to shut down groups, so to shrink it to 0 instances, the groups where the electricity is going to emit the most CO2, and keep only the one which is the greenest. So in this example, Ireland is the best option, so it's going to shut down everything and keep only Ireland. So I'm going to show this example. Yes, and another thing that whenever you are hitting an instance, is going to just display this fully displayed map. But you get it. So it's going to display this map of Europe and showing where it's replying from. So the instance knows where it's based and it's going to reply, hey, I'm from Ireland. And just what it does. So, and I have this UI of this green scalar, let's call it. And this UI shows the different regions, what's the carbon intensity of these different regions, and what are the number of instances. So I'm based on AWS, those are auto-scaling groups. So in this example, I have 2 instances in Europe West 1, which is Ireland. So what it does also is whenever an instance is coming up, it's going to use Chef Habitat basically to load the application. So it's called demo HTTP. And when it's running, when it's installing it, there is a hook, which is an initializing hook. And in this hook, I'm going to curl an endpoint from the instance. So this endpoint is provided on all instances by AWS, and it's going to give you a lot of information on the instance you are on, including the region. So I just stick the ID of this region in JavaScript as a variable, and then my entire project is going to read this JavaScript and showing it to you. So that's basically what it does. When you hit the global endpoint. So here is the IP address of the global endpoint, and basically it's redirected only in Ireland because there is only 2 instances only in Ireland, and the instance reply, okay, I'm in Ireland. Now I'm gonna change. So basically I mocked the carbon intensity API just for the purpose of this demo. So basically, I have just 2 endpoints. One is just giving you the different carbon intensity of different regions, and one is my hacking endpoint. So yeah, in there, I'm gonna reduce in France the carbon intensity from 120 to 20 in this example. So quick check if it's right. Yes, it's well 20 for Europe, for France. And if I check that, yes, so now it's the French region which is in green, but still I have my 2 instances in Ireland. So progressively those 2 so I'm gonna have, it's not the instances are not being moved, obviously. So there's 2 instances that are going to pop up in the West 3 regions, and once they're going to be up, the 2 instances here are going to be shut down. And normally, should not have any downtime here. So it's still replying from Ireland, and we're going to wait a little bit to come back to that. What else I can show you in the meantime? Yeah. Here you have the Boa Vista API I was showing you before, where you can play with those different, let's say, different data. And yeah, again, be careful with that because it's giving you the manufacturing for the entire lifespan of your hardware. Working. Yeah, you see those 2 instances coming up. So I don't know if someone have a quick question now. While we're waiting for that. No? It's gonna come. So yeah, basically the idea behind that is to leverage where the electricity is the greenest, and but there is a lot of rooms for improving that. For example, if I change that every single minute, it's going to be a big mess. So you probably need to do that maybe once or twice a day, every hour if you want, maybe on some part of your infrastructure, but that could be a great thing to do. Another limitation of that, obviously, if you need to be based somewhere, for example, if you have your own data center in the basement, you cannot move it, obviously. But some companies have mixed architecture, they can have that for some of their loads, so it clearly depends. But there is one thing people can do is shut down instances while not using it, obviously, and another quick win is to have those asynchronous tasks being run somewhere, and when electricity is greener, that's one of the bigger thing on the reduction of the cloud, of your cloud infrastructure. But keep in mind, you still need to optimize your code. So here, looks like all instances have been moved to Paris. So I'm gonna check again, and still way. So it's probably a cache issue. Yes, it was a cache issue. So now they are all they are all replying from France. Yeah, that's here. So I'm gonna wrap up. So yeah, if it's moving to France, it shut down instances, bring us those up, and that's it. So what are the takeaways of this conference? So the first thing you need to know if you want to go towards some carbon awareness of infrastructure is obviously to get and collect the usage metrics. Once you have that, so basically the percentage of use of your CPU, your RAM, of your different process, etc., etc. Once you have that, you have some ways to calculate, and you have some tools to calculate the kilowatt hours. And then if you know where your software is deployed, you can have the estimation of the carbon emission in terms of gram of CO2 per hour. And then when you have that, it's good to have it injected in some visualization dashboard where you can plan, analyze, think, relate, and try to come up with some actions. So some actions is to reduce the number of instances, schedule according to the grid CO2, blah, blah, we already talked about that. And if you do that automatically, using some DevOps good practice and automations and stuff like that, it's basically called carbon awareness. Thank you very much. You have the QR code for the slides if you want to click on some sources and some links. And again, I encourage you to check the Green Software Foundation website where there is a lot of good resources, and they also host a podcast named Environmental Variable. So it's good to have to listen to this podcast. It's pretty interesting. Thanks a lot. And if you have time for questions, I'm here. Otherwise, you can find me somewhere. Yes, please.
How many companies have like quality requirement? Oh, sorry. How many companies do really have as a quality requirement the sustainability? Do you have any experience?
No, that's a very interesting question because it really depends on countries. In France, for example, it's if you got money subsidies during the COVID crisis, the government asks you to report to have a sustainability report and to report your emissions. So that's one of the most advanced legislation in the world because basically a lot of companies had this money during the COVID crisis. On European level, there is this directive that are coming for big companies. So basically all the big companies listed on stock markets, they are more or less forced to do that. And for smaller companies, they are more working toward commitments, which is basically they're planning to be net zero, and for that they need to show their sustainable report, but it's kind of optional. But a lot of companies are doing that because they're all copying what the other companies are doing. So you can just, I tried that. If you want to know what is the sustainability report of any company, that basically I would say like 50% of what I checked is you have that. If you go on, I don't know, like Etsy, the marketplace for, it's like a bit like Vinted, it's a marketplace for DIY stuff. And the carbon emissions for the cloud was 12,000 tons, I think, 12,000 tons of CO2 per year, only for the cloud. So we have those data, and that's why they have these different scope 1, scope 2, scope 3 for sorting this out. But again, it's still optional, it's still on a voluntary basis, and there is still no regulation of what I know forcing you to reduce it, just for knowing what is the footprint. Yeah, other questions? So thank you very much. I'll give you back 5 minutes.